Early computers such as the ENIAC had to be physically rewired to perform different tasks, which caused these machines to be called fixed-program computers. Since the term CPU is generally defined as a device for software computer program execution, the earliest devices that could rightly be called CPUs came with the advent of the stored program computer. The idea of a stored program computer had been already present in the design of J. Presper Eggert and John William Mauchly's ENIAC, but was initially omitted so that it could be finished sooner. On June 30, 1945, before ENIAC was made, mathematician John von Neumann distributed the paper entitled First Draft of a Report on the EDVAC. It was the outline of a stored program computer that would eventually be completed in August 1949. EDVAC was designed to perform a certain number of instructions, or operations, of various types. Significantly, the programs written for EDVAC were to be stored in high-speed computer memory rather than specified by the physical wiring of the computer. This overcame a severe limitation of ENIAC, which was the considerable time and effort required to reconfigure the computer to perform a new task. With von Neumann's design, the program that EDVAC ran could be changed simply by changing the contents of the memory. EDVAC, however, was not the first stored program computer. The Manchester Small-Scale Experimental Machine, a small prototype stored program computer, ran its first program on the 21st of June 1948, and the Manchester Mark I ran its first program during the night of 16 to 17 June 1949. Early CPUs were custom designs used as part of a larger and sometimes distinctive computer. However, this method of designing custom CPUs for a particular application has largely given way to the development of multipurpose processors produced in large quantities. This standardization began in the era of discrete transistor mainframes and mini-computers and has rapidly accelerated with the popularization of the integrated circuit (IC). The IC has allowed increasingly complex CPUs to be designed and manufactured to tolerances on the order of nanometers. Both the miniaturization and standardization of CPUs have increased the presence of digital devices in modern life far beyond the limited application of dedicated computing machines. Modern microprocessors appear in electronic devices ranging from automobiles to cell phones, and sometimes even in toys. Neumann is most often credited with the design of the stored program computer because of his design of EDVAC, and the design became known as the von Neumann architecture. Others before him, such as Konrad Zuse, had suggested and implemented similar ideas. The so-called Harvard architecture of the Harvard Mark I, which was completed before EDVAC, also utilized a stored program design using punched paper tape rather than electronic memory. The key difference between the von Neumann and Harvard architectures is that the latter separates the storage and treatment of CPU instructions and data, while the former uses the same memory space for both. Most modern CPUs are primarily von Neumann in design, but CPUs with the Harvard architecture are seen as well, especially in embedded applications. For instance, the Atmel AVR microcontrollers are Harvard architecture processors. Relays and vacuum tubes, thermionic tubes, were commonly used as switching elements. A useful computer requires thousands or tens of thousands of switching devices. The overall speed of a system is dependent on the speed of the switches. Tube computers like EDVAC tended to average 8 hours between failures, whereas relay computers like the slower but earlier Harvard Mark I failed very rarely. In the end, tube-based CPUs became dominant because the significant speed advantages afforded generally outweighed the reliability problems. Most of these early synchronous CPUs ran at low clock rates compared to modern microelectronic designs. Clock signal frequencies ranging from 100 kHz to 4 MHz were very common at this time, limited largely by the speed of the switching devices they were built with.